Hello, you guys. Welcome back. It's Mr. Romero. Today we are going to cover heat transfer. So, how does heat go from one place to another? So, just a quick review. We last talked about solids, liquid, and gases as the three states of matter. Very quickly, let's provide a quick overview. Solids are practically the state of matter where the atoms and molecules are really rigid. They maintain their shape. So if you grab this shape and put it in a different container, this shape will stay the same. If we have a square, that square will maintain its shape no matter in what container it's in. It also has a fixed volume. So if here I have 18 atoms, those 18 atoms are going to maintain 18 atoms within that specific shape. No atoms are going to change. They're going to maintain the amount of volume that they have in that specific shape. Something about liquids is that here the atoms are not as rigid, and they're not as rigid because these atoms are able to move around freely. They're able to move around more than they can with solids. Here, they have no fixed shape, so they're able to take the shape of their container, and they have no fixed volume because they have a fixed volume because if I start off with 30 atoms, I still have those 30 atoms, no matter in what container I put it in. As long as I'm transferring all of the liquid over and nothing is left behind, I should have the same amount of atoms. So no matter in what container they're going, they still maintain their volume because nothing is really changing. You're just changing the container that they're in, and liquid does mold to whatever container they're in. And finally, you have these little rascals. You have gases which are not rigid at all because they are also able to move around freely and they have no fixed shape. They mold themselves to whatever container they're in, but they also don't have a fixed volume. And they don't have a fixed volume because they are able to um, kind of go in all different directions. So in one moment you'll have one specific volume, and then in another you'll have another different volume. And it just depends on how sealed the container is. Um, Regardless, though, in all these three states of matter, they're all vibrating in place. They're all slightly moving. Just that solids are compacted, liquids are not as compacted, and gases are able to move freely. We also talked about the different states of matter. We're not going to dive too deep into it. Just know that we are able to go from a solid to a liquid and a liquid to a gas by heating or cooling things. For example, a solid to a liquid, you're able to like get an ice cube and have it melt to become a liquid through the process of melting. You're taking whatever energy it has, and you're actually heating it up. You're making it hotter. So this is a diagram of how we can do phase changes, how we can go from one thing to another, how we can change from one phase to another phase. And that's something we covered in the last lecture video. Now I want to talk about heat transfer though, because we are able to go from one thing to another through the transfer of heat. Um, Heat transfer, or a fancy word for that is thermal energy transfer, is the flow of heat due to temperature difference. So we have three ways to do that. We have conduction, convection, and radiation. And it all goes from one thing that's the hottest to the thing that's least hottest. So it always goes from hot to cold, hot to cold, hot to cold. So a fancy word for heat transfer is thermal energy transfer. So if you hear me say the word thermal energy, I'm referring to heat. Okay? So, big difference between heat and temperature is that heat is basically how much energy is being given into an object. And temperature is basically you checking how much energy that is. So heat is how much energy is being released. Temperature is just measuring how much energy got released. Um, but remember, in either case, when we're talking about energy transfer, it always goes from hot to cold, just like this arrow shows you. It goes from the hottest, which is red, to least hottest, which is blue. So, in summary, heat is how much energy we're putting into something, and Temperature is the measure of how much of that energy got put in. So, quick summary: heat is, uh, thermal energy is another word for heat energy or heat transfer. And we're able to go from one thing to another through the process of having energy go from hot to cold, hot to cold, hot to cold. And there's three ways of doing that: through conduction, convection, and radiation. We're going to dive into each one of them individually. But before we do that, I want to emphasize to you that again, it always goes from hot to cold, hot to cold, hot to cold. And we do have three ways that things can go from hot to cold, and that is through conduction, convection, and radiation. First one up is conduction. What is conduction, Mr. Romero? And that is conduction is heat energy moving in a solid by direct contact. So when things go from a solid to a solid or from a solid to a liquid, it just needs to be direct contact. So conduction is the conducting of heat through direct contact. And usually it's solid to solid. Um, and here's a good example of it. Here we have a flame. It's making direct contact with this metal rod. You are conducting heat. You're transferring heat from this to that, and it's going from the most hottest to the least hottest. So it always goes from hot to cold, hot to cold. So in this example, the arrow would go to the right. You're going from the hottest to the least hottest. And this is what I mean. You go from the most hottest to the least hottest, which is over here where the gray area is at. And this is the direction it's traveling. It's going from left to right, from the most hottest to the least hottest. So, again, conduction requires direct contact. You're making direct contact from one thing to another. And that usually requires you to make direct contact with solids. So, here are a couple of examples. We can have something like touching a hot stove, ironing a shirt, ice melting in your hand, or walking outside without shoes on a really hot day. So let's dive into each individual one. Here, touching a hot stove, like actually touching it, so grabbing your hand and putting it on the stove, is an example of conduction, heat transfer, because through the process of conduction, we're able to conduct heat from the stove to the hand, from hot to cold. So from the thing that's the most hottest to the thing that's the least hottest. So it always goes in this direction, from hot to cold. So if you grab your hand and put it directly on the fire, that is a process called conduction. You're conducting heat from hot to cold. Another example is ironing a shirt. You're going from hot to cold. The hottest thing here in this example is the iron. It's getting transfer of heat directly to the shirt. So it's going from the hottest, which is the iron, to the least hottest, which is the shirt. That process is called conduction. Ice cubes with the hand. Here in this picture, we have the hand as the most hottest. We have the ice cube as the least hottest. It's actually cold. So here we have heat transferring from the hand to the ice cubes. So it always goes from hot to cold, from the thing that's the hottest to the least hottest. And that process right there is called conduction. Sand, a hot sand, and you stepping on it is a example of conduction, because the thing that's the hottest in this example is actually the sand. So the sand is absorbed all that heat, and it's just finding something to let that heat get transferred to. And the thing that was there was your foot. So heat got transferred from the hottest to the least hottest, which is the foot. This process right here is called conduction. You're conducting heat from hot to cold. Now let's dive into the second form that we can transfer heat, and that is through convection. Convection, convection. Convection basically requires a current, things going up and down or side to side. But it doesn't matter. They all require a current, basically going in circles. This is what I mean by in circles. Conduction is basically heat energy between liquids or gases. So, conduction is all about solids, Convection is all about liquids or gases. Um, and it always goes from hot to cold, where the hot thing goes up and the cold thing goes down. So it always goes hot goes up, cold goes down, hot goes up, cold goes down. And it all goes in something called a convection current. So it's going in a circle, in a circular motion. Hot goes up, cold goes down, hot goes up, cold goes down. It's circling in a circle. Um, Here's an example of a hot air balloon. On this end, here's where we have the fire at. And we have the the flame right here on a hot air balloon, and it's letting off some thermal energy. The thermal energy is going to go up, hot goes up, and then the colder air is going to go down. So hot goes up, cold goes down, hot goes up, cold goes down, hot goes up, cold goes down. So this is an example of a gas. So here we have gas circulating in a convection current. We have it going in a current, up and down, up and down, up and down, up and down, up and down. So hot goes up, cold goes down, hot goes up, cold goes down, hot goes up, cold goes down. That process is called a convection current. This heat transfer is called convection. So convection goes hot goes up, cold goes down. Here's an example of convection. Hot goes up, cold goes down. Hot goes up, cold goes down. Hot goes up, cold goes down. If you remember that for convection, that hot goes up, cold goes down, um, you'll be fine. You'll understand that it always involves liquids and gases, and those are the easiest examples to identify convection through liquids and gases. Here's an example. Here we were talking about liquids. Hot goes up, cold goes down. Here we're talking about gases. Hot goes up, cold goes down. So as the hot air is rising, it's pushing the colder air down into this space heater. So here we have a heater in something like a hotel or someone's room, and it's taking all that cold air in, and it's circling all that cold air, and it's heating it up through thermal energy transfer. It's transferring thermal energy, and it's heating up the air, and it's pushing it out. And as the hot air rises, the cold air drops, and it continues in this convection current. It continues in this cycle. Here are a couple of examples. Boiling water is an example of convection. A radiator heating a cold room is an example of convection. A steaming cup of coffee is an example of convection. And Earth's mantle is an example of convection. First off is boiling water. Boiling water is an example of convection because hot goes up, cold goes down. Hot goes up, cold goes down. So you have a convection current going up and down, up and down, up and down, to the point where enough convection currents of hot goes up, cold goes down in the liquid will eventually make the water all turn the same temperature. So initially the hottest was down here, but after enough convection currents, the entire water will be the same temperature. So hot goes up, cold goes down. Hot goes up, cold goes down. Another example of convection is a space heater. So space heater is transferring thermal energy by taking in the cold air and letting out hot air. So it's going from hot goes up, cold goes down, hot goes up, cold goes down, hot goes up, cold goes down. It's taking, it's pushing out the hot air and taking in the cold air that's coming towards the bottom of the room. So um, it circulates in a convection current. That is why it's called convection. It's moving air in a circular fashion. Here we have a third example, and that is coffee steam. So here we have a coffee. It's not on a fire. It's just chilling on a table. And on this table, there's nothing really heating up the cup of coffee. So because nothing is really heating up the cup of coffee, here we have a liquid, and that liquid's letting off some steam. Well, the reason why your coffee is getting cold is because um, there's a convection current, and the convection current is slowly cooling down your coffee. So hot air goes up, and then cold air eventually replaces that hot air space, and it goes in a circle. So hot goes up, cold goes down, hot goes up, cold goes down, hot goes up, cold goes down with this gas, to the point where the liquid on top right here of the cup of coffee is cold. And eventually the entire cup of coffee will be cold due to a convection current. So the current is going up and down, up and down, up and down, up and down, to the point where the cup of coffee gets cold. Convection current also happens on the Earth's mantle. And this is our final example for convection. The Earth's mantle is an example of convection because down deep into the earth, there is magma. And that magma, which is that red hot stuff that can really burn you, that magma circulates through a convection current too. So the magma closer to the surface is really hot, really, really, really hot. And the one closer to the center of the earth over here is still hot, but not as hot as the one up here. So the hot goes up, and then the colder magma comes down, and it just circulates in that direction. Hot goes up, cold goes down, hot goes up. So scientists have also determined that the rotating of magma in the earth is also an example of a convection current. Now, we're going to talk briefly about radiation. We're not going to dive too deep into it, but we are going to discuss what radiation is. And radiation is really cool because it doesn't require a solid coming into contact with another solid. It doesn't deal with liquids and it doesn't deal with gases. It does its own thing. It doesn't require a state of matter to move energy from one place to another. And this is what I mean. Heat energy can travel in space by infrared or thermal radiation. So it doesn't require a state of matter. It can even travel out in outer space through something called thermal radiation. The reason why we're just going to briefly cover radiation is because we haven't learned anything about the electromagnetic spectrum yet. And we will later on, but not right now. Just know that radiation is basically the transfer of heat from one place to another, and it doesn't require, it doesn't rely on physical contact. It doesn't require direct contact between things. It can just travel in space. This is what I mean. This is all you really need to know for radiation, and that is it does not require a state of matter to move through, but can typically move through air or outer space. Heat is transferred in all directions, not just in a current or through direct contact. Here's an example. Conduction is direct contact. So direct contact with the handle and direct contact from the handle to the pan. So the pan and the handle are making direct contact. They're transferring heat with each other. Convection is through a convection current, through basically the cycling of hot goes up, cold goes down, hot goes up, cold goes down, hot goes up, cold goes down. That's an example of convection. So heat gets transferred in the hot goes up, cold goes down fashion. But here we have radiation. And radiation, like it says right here in yellow, heat is transferred in all directions, not in a current. So radiation basically lets off heat in all 360 degrees. So it doesn't just let off heat into the pan, it actually lets off heat in all different directions, not just in one direction or not just in a current fashion. It transfers it in all directions. Um, this is another example of what I mean. Radiation travels in all directions, and it's not just in one direction. Conduction is through direct contact. Convection is requiring liquids and gases. Radiation really doesn't require anything. It can go through the air, but it doesn't have to. It basically follows its own rules. It just transfers heat from one thing to another in all 360 degrees. Here's the best example I can think of. So when you are lighting a fire, um, fire doesn't just kind of hit your hands right here. You're not the only person that can feel the fire. Multiple people can be around the fire and enjoy the fire because radiation is let off in all 360 degrees. It's in all different directions. So Again, heat is transferred in all directions, not just in a current. It doesn't just go hot goes up, cold goes down, hot goes up, cold goes down. It literally just transfers heat in all directions. Here are a couple of examples. So a campfire's heat, like we discussed, is an example of radiation. It lets off heat in all different directions. A microwave heating food is an example of radiation because a microwave heats all, it lets off radiation, and it doesn't just heat up one piece of the pizza, it heats up the entire pizza, all 360 degrees of the pizza. And a light bulb is an example of radiation because it lets off thermal energy, it transfers heat from one place to another in all 360 degrees. It doesn't just transfer light in one direction, it transfers light in all different directions. And infrared warmers in a restaurant. That's an example of radiation because it doesn't just transfer heat to keep the food cold. It doesn't just transfer heat to keep the food warm in one direction. It transfers heat in all different directions. So all part of the food can get warm. These are four examples of what radiation is. And here's a picture to reinforce all of that. So here we have convection, and convection is hot goes up, cold goes down, hot goes up, cold goes down. And convection can require liquids and gases. Conduction can require solids. So one solid making contact with another solid. Here we have the solid hand making contact with the solid pan. Heat gets transferred from hot to cold. So hot to cold, hot to cold. And radiation doesn't require a state of matter. It just does its own thing. It transfers heat in all 360 degrees. So here it's transferring heat in this side of the pan. This part is transferring heat in that side of the pan. But also, if I were to stand right here and get very close to the pan, I can feel the warmth. I can feel the thermal energy because these little zigzag lines are also hitting in this direction. They're hitting in all 360 degrees. And finally, here's an example of radiation with the sun. The sun doesn't just hit California. The sun hits California, the rest of the United States, the rest of South America, North America. The sun also hits parts of Europe. The sun hits all places of the earth. The sun is the best example that I can think of for radiation, for where we're at right now with the unit. So radiation just hits in all different directions. So let's practice. What do you think A is? Good. It's conduction. And that is heat being conducted from hottest to coldest through direct contact. This metal is making direct contact with the fire. So it's going from hot to cold. B. What do you think B is? Good. It's convection. Convection is hot goes up, cold goes down. Hot goes up, cold goes down. And convection deals with gases or liquids. So here we have this these zigzags. These represent heat. Gas. This represents gas. So it's going up and down. Hot goes up, cold goes down. So this is an example of convection. So this guy can stay warm through the process of convection. Or this guy can also stay warm through the process of, what do you think C represents? This guy can also stay warm through the process of radiation. Because remember, radiation doesn't require a state of matter. It can. Here, radiation is going through air, and it's going through air in all 360 degrees. So the fire is going in all different directions, not just in one. It's not just hitting this guy, it's also hitting this guy over here off to the side. And that wraps up our lesson. Good job, you guys. You guys did